Welcome back, Chem 20s. We're going to continue our lesson on concentration of ions. What I would do is I would pause the video, try example 2 for yourself because it goes right along with what we did in example 1, and then unpause the video to check your work. Well, if we look at example 2, we are looking at a concentration of 0.12 moles per liter of barium hydroxide, and we are going to calculate the concentration of each ion. We're going to assume that barium hydroxide completely dissociates. Now, it says that about barium hydroxide because if you were to check your solubility table, you would see that it naturally would not dissociate. Since it's telling us that we're going to assume that it does, do not go against the question. I still would like you to do this because we are going to make this assumption. So never go against. If they tell us something in the question, we're going to take it as fact. So I wrote the dissociation equation. Again, 1 barium, 2 hydroxide. I added a 2 here for 2 hydroxide. We're going to check our charges. 2 minus plus 2 positive. No charge on the right, no charge on the left. What I'm going to do is I'm going to do what I did on the last question is I am going to change my pen color for a second and write down my concentration of 0.12 moles per liter. I tend to do this in my class, and this is a big deal for later on. So now that I know the concentration of barium hydroxide and I've written it underneath, what I'm going to do is I'm going to find the concentration of both ions. So to find the concentration of barium ion, take the concentration you know, so 0.12 moles per liter of barium hydroxide. And we're going to multiply by, and we're going to play a little game of leapfrog, 1 mole of Ba2 positive. And then our little game of leapfrog is we're going to leapfrog back 1 mole of barium hydroxide. We'll notice that my moles are going to cancel out. Barium hydroxides are going to cancel out on top and bottom. And we're going to take 0.12 moles per liter, times it by 1, and divide it by 1. And no surprise here, number is going to stay the same in moles per liter, the only unit we have left. And this is for Ba2 positive. Let's start again. And this time we're going to find hydroxide ion. So 0.12 moles per liter of barium hydroxide. And again, we're going to do it the exact same way. We're going to start with the information I know in red. We're then going to play a little game of leapfrog, this time to the hydroxide. So we have 2 hydroxide ions. And then we're going to take our little game of leapfrog and we're going to leap back 1 mole of barium hydroxide. Again, my moles are going to cancel. Barium hydroxide on top and bottom is going to cancel. So we're going to take 0.12 moles per liter times by 2, divide by 1. And so that's going to double this to 0.24 moles per liter. And this is for the hydroxide ion. Now, people might ask, Mr. Kemp, I don't understand. Why do I have twice as much? Oh, hit the wrong button. Why do I have twice as much hydroxide? Well, again, let's look at this in a picture form. If I have barium hydroxide and I dissolve it in water, this substance, this molecule is going to break into barium ions and 2 hydroxide ions because for every barium that comes out of solution, 2 hydroxides are going to come out. So as you can see, we have double the amount of hydroxide ions that we have barium ions. So it makes sense that the concentration of hydroxide is going to be double that of barium. We've got to get out of the mindset of volume, and we have to start thinking about this in the idea of concentration. And in our case, concentration of ions. Okay. What I want us to do is let's try example number 3. Now, I'm going to go back and grab my pen color here. I got my green, beautiful. Okay, example number 3. Determine the concentration of aluminum and sulfate ions in a solution made by dissolving 3.29 grams of aluminum sulfate. So let's look up aluminum sulfate. And aluminum sulfate in my data booklet says that it does dissociate. So we can write the dissociation equation. So Al2 bracket SO4 bracket 3. This time I'm going to write it as a solid because it gave it to me as a mass. So I'm weighing it out as a solid first, and then I'm going to dissolve it in the volume here. So when this guy dissociates, it's going to dissociate into his ions. So that's going to be aluminum ions, and that's going to be sulfate ions. Again, I want you to think about in the compound, how was this built? Aluminum was the cation, sulfate was the anion. So I have two aluminums, so I'm going to need two aluminums. Three sulfates, I'm going to need three sulfates. 6 positive plus 6 negative, no charge on the right, no charge on the left. Now, it's naturally at this time where I would get my red pen and I write down the concentration of one of these substances. If you notice, we don't know the concentration of any of these. However, I do know the mass of aluminum sulfate. So anytime I know the mass, if I calculate the molar mass of aluminum sulfate, I can find moles, and then moles with volume, I can find concentration. So this is going to be some extra steps. This is going to use previous knowledge that we've built in the last few days. So first thing we're going to do is we're going to find the moles of aluminum sulfate. So I'm going to take 3.29 grams and I'm going to divide by, and now I'm going to figure out the molar mass. So 2 times 26.98 plus, I have 3 sulfurs at 32.07, plus I have 12 oxygens at 16 apiece. So my molar mass is going to be 342.17 grams per mole. So I'm going to go 3.29 divided by that answer in my calculator. I have 3 sig digs, so I have 0.00962 moles. Now that I know the moles of aluminum sulfate, I dissolved it in 200 milliliters of water so I can find the concentration of this solution. 0.00962. And I want to remind you that although we write that number down, we're going to use the full calculator number. I like my numbers in moles per liter for concentration. So I'm going to divide by liters. So I'm going to convert from milliliters to liters, divide by 1,000. So I already have the full number in my calculator. So I'm going to divide by 0.2. And my answer in 3 sig digs is 0.0481 moles per liter. Now, that is my concentration of aluminum sulfate. So I'm going to actually take my red pen and I'm going to write it right there. Now, this is not the number we're using, right? We're still going to use my full calculator value. I'm going to try to get some more paper here. So now I'm going to calculate the concentration, it says, of both ions. So I'm going to find aluminum ion first. And we're going to follow the steps you just learned today. So I'm going to take 0.0481 moles per liter of Al2 bracket SO4 bracket 3. I'm going to multiply by mole ratio right here, 2 moles of aluminum ions. And I'm going to divide by, little game will leapfrog back, 1 mole of Al2 bracket SO4 bracket 3. Again, my moles cancel, my aluminum sulfates cancel. So I'm going to take this full calculator number and times by 2. My answer is going to come out to be 0.0962 moles per liter for aluminum ions. Again, I'm going to do the whole thing again, this time for sulfate ions. Take the number I started with, 0.0481 moles per liter. And I want to use the full calculator number. So if that means you have to type it all in again, you'll have to do that. We're going to leapfrog times by 3 moles of sulfate. Divide by, going to leapfrog back 1 mole of Al2 bracket SO4 bracket 3. So moles cancel, aluminum sulfates cancel. I'm going to take that full calculator number, this time times it by 3, and my number is 0.144 moles per liter of SO4 2 minus. Now, if I take a look at this, you would get 1 mark for the dissociation equation. I would give you formula, substitution, answer, 3 marks. Formula, substitution, answer, 3 marks. 1 mark for the concentration statement, incorrect sig digs with units. 1 mark for the concentration statement with sig digs and units. Please go ahead and try question 4 for yourself. When you're ready to check your answer, please unpause the video and take a check for yourself. So we are going to do aluminum acetate. It does dissociate. Again, 1 aluminum, 3 acetates, 3 acetates, 3 minus plus 3 positive, no charge, no charge. Wonderful. Now, in this question, it is a little bit different. So I want to look at that difference for a second here. And if I look at this difference, and I don't know why I'm clicking random buttons, if I want to look at this difference for a second here, we would like to make 500 milliliters of something. Now, I know the concentration of acetate ion. So again, let's just grab my red pen and we'll write that in there. My concentration of acetate ions is 2.17 moles per liter. Now, we don't have to always solve for the substance on the left. We can honestly have any concentration and this process will work. So I can find right away the concentration of aluminum. If I know the concentration of acetate, I can find the concentration of aluminum acetate. And so to find the concentration of aluminum acetate, I'm going to take the concentration I already know, 2.17 moles per liter of CH3COO minus. I'm going to multiply by, so little game of leapfrog this way this time, 1 mole of Al bracket CH3COO bracket 3 divided by, again, we're going to then jump back here to where the number was, 3 moles of CH3COO minus. Again, moles cancel, acetate cancels. So take 2.17 times 1 divided by 3, and my answer in 3 sig digs is going to be 0.723, and this is going to be moles per liter. So that is the concentration now of my aluminum acetate. Well, we are wanting to find the mass of aluminum acetate. So if I know the concentration and I know the volume, I have this formula and I can use it to solve for moles. So moles equals C times V. So my concentration, 0.723 moles per liter. My volume, 0.5000 liters. So I can get my moles to be times that number by 5, 0.362 moles. Almost there. I know I convert from moles to mass. So I've got a formula. Moles equals mass over molar mass. I'm solving for moles. So I'm going to multiply these two. Mass equals moles times molar mass. So 0.362 moles times the molar mass, which I have to calculate here. So my molar mass is going to be aluminum, 26.98, plus I have 6 carbons at 12.01, plus I have 9 hydrogens at 1.01, plus I have 2 times 3 is 6 oxygens at 16 apiece. So my molar mass is, I believe, 204.13 grams per mole. So I'm going to multiply my 0.362 times my value, and I'm going to get a mass of 73.8 grams. Again, this is no different than question 3, except we're going in a backwards order. Still going to be worth lots of marks. Pay attention to sig digs. And again, just be careful of all the information. The only new thing we added today was these first 2 steps. Everything else came from previous lessons.